Okay, if you're prepping for your CCNA exam, or honestly, even if you're already managing an enterprise network, you know the struggle. Analyzing existing IP subnets is just a massive, time-consuming bottleneck, right? But what if you could bypass all that complex math entirely? Today in this explainer, we're going to unlock a crucial networking skill that is literally going to save you massive amounts of time.
So most people take minutes to calculate a subnet. They sit down, they sweat over their scratch paper, and eventually, they just run out of time. But look at the challenge we've got right here. Finding the resident subnet of an IP address in under 15 seconds. Think there's no way that's possible? Stick with me, because we're going to do exactly that.
But before we dive into the math, let's ground ourselves in reality for a second. Just look at this dense web of cables. Every single networking task, every troubleshooting ticket where you're trying to figure out how a host connects through this crazy environment, it all starts with discovering an IP address and its subnet mask. I mean, if you can't map this out, you definitely can't route the traffic.
Section 1. The Subnetting Sandwich Problem. Imagine you walk into a shop, order lunch, and they hand you a 2-kilometer-long sandwich. You can't eat that by yourself. It's completely unmanageable. Well, a massive Class B network is exactly the same thing. It just has way too many IP addresses for one single broadcast domain. So what do? We chop it up into useful, meal-sized pieces. And those smaller, digestible pieces, that's exactly what we call subnets.
Section 2. Meet your resident subnet. Think about it like this. Just like how houses in the same town share a postal zip code so the mail carrier can actually sort the deliveries efficiently, computers on the same router link share the same subnet. It's how routers sort and route data properly. Basically, if two hosts aren't separated by a router, they're in the same subnet. If they are separated by a router, different subnets. It really is that simple.
So the absolutely crucial takeaway here is that every single IP address lives inside a resident subnet. And to map the network properly, we have to find two specific boundaries. First, we need the subnet ID, which is the absolute lowest number in the subnet, used by our routing tables. And then we need the broadcast address. That's the highest number, and it's used to send packets to all the hosts in that specific subnet.
Section 3. Escaping the binary trap.
Now just look at this totally exhausting traditional process. This is exactly where network engineers lose their minds and, their valuable time. You get an IP address, and to find the subnet ID, you're supposed to convert it all into 32-bit binary. Then you convert the mask. Then you do this Boolean AND logic to wipe the host bits to 0. Honestly, doing binary conversions by hand takes way too long, especially for a fast-paced exam. You're probably looking at all those binary zeros and ones in your textbook right now and wondering, okay, is there a faster, better way to actually survive my CCNA test? Well, what if I told you that you could completely ignore Boolean logic?
Section 4. The decimal shortcut.
All right, so we start with what we call easy masks. These are masks made entirely of 255s and zeros. You just look at your 4 octets. If the mask octet says 255, you literally just copy the IP address number straight down. If the mask octet says 0, you write a 0 down. And that's it. No binary required, absolutely zero Boolean AND logic. You literally just found your subnet ID in like 3 seconds.
But I know exactly what you're thinking. That easy rule is great, but it immediately raises a huge question. What on earth do we do when we hit an octet that isn't a 255 or a 0? Like, what do we do with a curveball like 240? Well, my friends, this is what we call the interesting octet.
Section 5. Finding the magic number. 256. Seriously, lock this number in your brain right now. This specific number is going to completely unlock the math for the interesting octet. And the best part is, we are never going to touch a single binary digit.
Okay, watch this shortcut in action. Take a look at that third column. Our mask is 240. That right there is our interesting octet. So you take our anchor number, 256, you subtract the mask value of 240, and we get 16. That 16 is our magic number. As for the rest, we just copy the 130 and the 4 because their masks were 255, and write a 0 at the end since that mask was 0. The only real math we even had to do was 256 minus 240.
So how exactly do we use that magic number of 16? It's super simple. All we do is count by multiples of our magic number. So 0, 16, 32, 48, 64, 80, 96, 112. Then we look at our original IP value in that interesting octet, which was 102. We simply find the multiple of 16 that gets us closest to 102 without going over. In this case, 96 is the clear winner. Pop that into the third octet, and boom, our final subnet ID is 130.4.96.0.
But wait, what about the broadcast address? To find the top end of the subnet, again, you do not need to invert masks or do Boolean ORs. You just take that subnet ID value we just found, the 96, you add the magic number, which is 16, then subtract 1. So 96 plus 16 is 112, minus 1 is 111. Bam! You instantly have your broadcast address, and your usable range is simply everything sitting right between the subnet ID and that broadcast address.
Section 6. Your new subnetting superpower.
Just look at what you just accomplished without a single drop of binary math. By simply identifying the magic number and applying it to the interesting octet, we completely mapped out the entire residence subnet. We found the subnet ID of 96.0, we found the broadcast address of 111.255, and we know the usable range starts at 96.1 and ends at 111.254. And you did all of this using only grade school decimal addition and subtraction. How cool is that?
So now that you've successfully escaped the binary trap, think about the immense advantage you have. When you sit down for those exams, or when you're actively troubleshooting a live enterprise network, you aren't going to be wasting time converting ones and zeros. So how will you use this newfound superpower to completely dominate your routing tables? I challenge you, grab a random IP right now, test it yourself, and see if you can beat that 15-second clock.